So here's a little activity just to get us started off. I want you to estimate, don't look it up, that ruins the fun, it'll ruin the activity. I want you to estimate the ages of each of these fairly famous people. Carson Wentz, a football player, Billie Eilish, a musician, Elton John, a musician, Kamala Harris, vice president to be, Prince George, Barron Trump, Pope Francis, Beyonce, and Snoop Dogg. Go ahead and guess those ages. Okay, I don't know if this is embarrassing yet, but here are the ages that I decided to guess. We'll see who's a better guesser. Hey, we're back. It turns out my guesses were really terrible. So Carson Wentz, as of today, he is 28 years old. Fill those in. Billie Eilish is 19. Elton John, 73. Kamala Harris, 56. I thought she was younger than that. Prince George, I way overshot. He's only 7. Barron Trump is still only 14. The kid never ages. Pope Francis, he is 84. Beyonce, I don't know why I thought she was so old. She's only 39. And Snoop Dogg, same thing. He is 49. Next thing I need you to do is make a scatter plot of those. So we're going to use the estimate as the x, comma, the actual as the y. So we're going to plot all of those ordered pairs. Let's start by making our x-axis, which is the estimated age, and the y-axis, which is the actual age. And then just start plotting your points. Yours will be different from mine. How can you tell by the graph whether you're a good guesser? Well, first of all, mine is very scattered, so I think mine shows that I am not a very consistent guesser. Like, these seemed a little more consistent. I don't know if they were good guesses, but then these were all over the place. I guess I was probably Beyonce, Snoop, and Kamala, right? So I'm going to write down that they would be consistent or close to a straight line. I'm going to kind of look ahead. The next question has us say what the graph would look like if we were a perfect guesser. So I think that'll help us get some insight into how our graph tells us if we're a good guesser. I'm going to use a different color, and I'm just going to plot like some points that would be perfect guesses. And I know we didn't have any 30-year-olds, but if we estimated somebody was 30 and we were a really good guesser, then they would have been 30. And if somebody was 60 and we were a really good guesser, we would have the point 60-60. And if somebody was 5, we would have guessed 5. And so that straight line kind of tells me where the perfect guessing line is. The perfect guesser's line would be that yellow line. And like I said, these numbers right here, these guesses right here, were pretty close to linear. They're not right on the line. These were all scattered about. So not only was it important that they were linear, but they should have been sloped a certain way, right? Like up 5 over 5, up 5 over 5, up 5 over 5. So I would say that that straight line should have a slope of 1. Since up 5 over 5 reduces to 1. So we would want to look at that to see if we are a good guesser. So we kind of already skipped to number 4. That's what the graph would look like if I were a perfect guesser. All of my dots would be right on that yellow line. Let's write the equation that corresponds to that yellow line. And if you remember, a line equation has all of its x and y values fitting this formula. The only things we need to fill in are the m and the b. If you need to write this down, it might have been a while. M stands for that slope, and b stands for the beginning point, or the y-intercept. And we already talked about how the perfect slope would go up 5 over 5, up 5 over 5, which reduces to 1. And the y-intercept, that just corresponds to which point is actually on the y-axis, and that would have been 0, since we would have guessed 0 for a 0-year-old famous person. So to finish up, the equation for the line would be y equals 1x plus 0. And we could simplify that. We don't have to write 1x, we could just write x, and we don't have to write plus 0. So the equation for that yellow line is y equals x, which totally makes sense, right? Because y stands for the actual age, x stands for the estimated age, and they should have been equal to each other. Crazy. We also already drew the perfect guesser's line on our graph. Are points above this line overestimates or underestimates? So I want you guys to pick out a point that is above the line and maybe label it with the person's initials. I'm going to pick this point because it was way above the line. For me, that was Kamala Harris. I thought she was younger than she actually was. And so points above the line mean that I was actually underestimating her age. Kind of backwards of what you'd think, right? So points above the line are underestimates. Because remember, your guess was the x value and the actual was the y. And if you're an underestimator, that means the y is going to be big compared to your x value. So if you go to an x value and then plot a bigger y value, it will wind up above that line. And this last question, does the graph suggest you are mostly over or under the actual ages? That's going to be dependent on your own picture. I guess on mine, I only had 2 people that were above the line. And then actually most of my other ones were under the line. Is that a perfect guess? Who was that? That was Carson Wentz. I was 2 years off. That probably should have been a little bit higher. So I guess Carson was a little bit of an underestimate too. But I would say I'm mostly under the graph, which means I'm an overestimator, right? So the point of all of that was just to get us thinking about points, again, graphing, and just to remind us a little bit of that y equals mx plus b relationship, slopes and y-intercepts, and hopefully you had a little fun trying to guess those actual ages.